Hi folks, so today's question guys is based off of the topic of transformation geometry. It is a question from the 2019 higher level junior cert paper, higher level, and it is question 5 on that paper based on transformation geometry. Okay, you can see here I've already the question kind of set up with the object here with point P and then point P1, P2, P3 and P4 located. But I'll just show you where I got that question now guys. So I've the question set up here on my tablet, and basically the question says, I'll just zoom in there so you can see it a bit better. It says the figure shows the logo for a lighting company. The logo is subject to transformation in the following order. So we can see the logo here. It kind of has a square box here, okay, that has 30 long, rectangular box that's 30 long, 20 high, and from the center of the rectangular box on the baseline it's up 20 and then up 30 to find the center, and then we have a circle up here that has a radius 25 and point P at the corner. To find P1 it is over 90 and up the same height as the top edge of the box there, so it's over 90 and up that height. To find P2, which is down here, from P it is down 70, because we can see the 70 over here, it's down 70, and then from this corner here down 70 over 45. To find P3 it is down from that 70, it's down another 20, okay, so just be aware of that, it's down another 20 from the original 70 from P down, and then to find it it's over 90 over 50. So it's over 90 over 50 and technically down 100 and, or sorry, not 100 something, technically down 90 millimeters then, okay? Over 90 over 50, down 90. And then to find P4, straight out from P all the way across is P4 over here, 90 plus 50 plus 90. So it says the logo is subject to transformations in the following order: axial symmetry from P to P1, central symmetry from P1 to P2, a translation from P2 to P3, and then a rotation anti-clockwise through rotation anti-clockwise through 90 degrees from P3 to P4. Okay, so part A, draw the given figure and locate all the points, and then determine and draw the image of the logo under each of the above transformations. Okay, it says note all geometric constructions must be clearly shown on your drawing sheet. Okay, so starting off guys, P to P1 by axial symmetry, that's what we're going to start off with there. Okay. So zooming out there guys, so in starting off this question guys, I'll just show you there for point P and where I actually started drawing this object so it fits on my A3 sheet. I have located point P, okay, for starting off this object here. It's 120 millimeters down, okay, from the top of my page, and it's 75 millimeters in. Okay, that's a good starting point. Okay, probably could have pulled it a touch left and maybe a touch up higher, but I feel that's going to be quite central from where P3 is, because I'm going to have to rotate that anti-clockwise over to P4. So always when you're starting these questions, you kind of have to consider what transformations you're doing and where you think the final object is going to finish up. Okay. So anyway, from P to P1 we have to do that part through axial symmetry. Okay, so the very first one is, what you would do here is you're going to connect P to P1. Okay, having connected P to P1, what I'm going to do now is I'm going to bisect that line. Sorry, just focus there again. Bisect that line. Pick a distance over halfway. Back here and do that one again. There we go. Having bisected that line, I am now going to draw in my axis. So go there. I think that'll do. Okay, and I'm going to write in there axis. Okay, you don't have to. If it helps, great. Just telling the examiner what I thought. Okay, axis for axial symmetry. Okay, just going to dull the light there a little bit guys. Now what I'm going to do next is to find all these points. Okay, I'm going to give them actual labels. Okay, so if this is P here, PQ, I'll do it like the alphabet. Okay, I'm going to call this one Q, PQ, R, S, and then I've also got a center point here, T. Okay, now I want to find the rest of those points under axial symmetry. Okay, so what I'm going to do is simply do a bit of sliding set squares, and I'm going to go perpendicular to all of those points. Because we can see here from P to P1 that the angle in here is perpendicular. That angle from P out to P1, okay, with our axis, the angle in there is perpendicular. So I do the exact same then with S, Q, R, and T. So S is going to be slightly further out. Do the same with Q, and the same with R. Okay, and probably further out there again. And then the same with T. So T is up there. And having done that, what I'm going to do then is I am going to put my compass point on the axis. I want to find S. So I'm going to find S1, which should be out the same distance at the opposite side. I want to find Q. So that'll be Q1. Same for R. And then finally the same for T. And there we go. So label them. So this is S1. I have to extend out my line there a little bit. This will be Q1, and this will be R1, and this will be T1. Okay, because P1 corresponds then with Q1 and so forth. At this point, guys, what I will do is, I just need to extend out that just a touch further. And there's my point. At this point now, what I would do to try and keep things symmetrical, okay, and correct in their correct orders, okay, I know PS and QR are parallel to each other. So what I would try and do is, once I draw in that P1 to S1, I would just check that Q and R would match up parallel as well. So I can literally slide in set squares, and then I can check that they are, and I'm happy with that. So there's P1 and S1. Okay, and then I can rotate to get perpendicular, and they should work out perpendicular, and they do. Happy with that. Okay, now there is nothing wrong with literally just coming along with your points and just doing it like that. Okay, that's absolutely fine because they should work out. Okay, but I'm just trying to keep everything accurate. Okay, because I know that these two lines are parallel, and then I also know that these two lines are also parallel. Okay, finally, I would also recognize that from the center of the line here, actually that's another point I should have got. Apologies, I should have actually connected that across. That's another one. From the middle, okay, I should have found this point right here. Okay, because that actually is what connects the outside of our circle tangent lines there. Okay, so I'm going to connect those up. So I know that's in the middle there. Having done that, I've got these lines here that I know they are parallel to PQ, and hopefully T will match up with it. Yeah, I'm happy with that. There we go. Okay, so that's our point right there. Okay, and now for T, what I'm going to do is I'm going to draw in my circle that has a radius of 25 millimeters. So I can take that radius from over here, and I can draw that in here. And do it as light as I can first of all, because I'm going to draw on my tangents then. Okay, and I know my tangents connect to the outside. Back to this point here. That's why I had to find that point. Okay, and I can put it in lightly there if you want. Okay, but obviously I only need to heavy in as far as there. And once again then I will heavy in my circle. It has a radius of 25 millimeters. Okay, so there we go. Now, just on that, guys, as well, I should probably have explained, and I'll just, move that up a tiny touch there so you can see that a bit better. But just on that, okay, we had a tangent here. We can see where the tangents are. Now, they haven't asked us to find the tangent, but generally what I would always do inside an exam, guys, is if I am getting a tangent, we know how to construct a tangent to a circle from a point. In this case, this is our point here. and this is our circle center point. Okay, so what we have to do is from where the tangent starts, which is at this point here, and we can see where it's going to be. Okay, we know the answer, we can see it there, we know the answer, but we have to exactly prove that point there. Okay, so to actually prove that, all you'd have to do is you'd have to connect this point to the center, bisect the line, and then swing a semicircle. Where our semicircle cuts through, we find our tangent point. Okay, our point of contact technically. But this line here is 50 millimeters. So half of 50, very simple. Okay, half of 50 millimeters is 25. So it's right there. Okay, which is where the circle is. It's right there. At that point there, I could do a semicircle. Okay, I don't even have to draw on the full semicircle, but you can see here, full semicircle, like that. And what it's actually showing me there, very important, is the point of contact, right there. And having found it there, I can literally do a straight line across and I find it here as well. Okay, if you want to do that at the very start, just showing the examiner, then obviously you know it's a tangent and so forth. Okay, so the next part of the question, guys, is we have to go from P1 to P2 through central symmetry. Okay, so what we're going to do, guys, is the exact same thing as we did last time. Connect P1 to P2 and then bisect that line, because we want to find our central symmetry point. Okay, so distance greater than halfway, that's bigger than halfway. There we go. Connect those up. Just mark the point in there. Right there, guys. I'm going to call that C for central symmetry. Okay. Now, if I want to find Q, Q goes through C. Everything goes through C in this case. I should say Q1. I want to find R. Obviously, you'd be using a sharp pencil, guys, not blunt biros like me. Just for demonstration purposes, I think it comes up better on the screen. Okay, so there's all them ones got. Now I'm going to find Q2. So that'll be out here the opposite side. I want to find R2, so just make sure you get the right line. And then I want to find S2, so you can see here. Ooh. There we go. Okay, label all those. I'll bring down T in a second. So this one here is S2. Then S2, this would be R2, and then we have Q2. Okay, so there's Q2, and finally I'll bring down T as well. Okay, and somewhere down there is going to be my T. So that distance there, down to here, and there is T2. Okay, so same principle, P and S join up, okay, parallel as best I can. And what I want to do is, before I draw it, I'm just going to do a bit of sliding set squares just to make sure. And what I can do is I can slide it down to check that R and Q are lining up parallel as well, and they are. So when they're lining up parallel, I know I'm quite happy. Okay, these are just little techniques, okay, and little practices, guys, to make sure everything stays neat and tidy for us as we go through the drawing. Transformation geometries, guys, often can get a little bit messy as you go further along the question, because our accuracy can get a little bit further out each time we do transformation geometry. Okay, so we always know that these are perpendicular, and as you can see there, I'm probably out about half a mil, quarter of a mil there, but you make it work for you. Okay, so there's kind of the base been flipped. Okay, I know I have a circle that has a radius of 25. I'm going to draw that in construction first. Take it from here. I've found the center T. Okay, there we go. So there's my T, and I know as well that T, the line here connecting T down to the base, is parallel to these edges here. This edge here, parallel, parallel. Okay, so as long as I'm parallel to the line there, S, so I'll go parallel and I'll rotate it because that one is just a bit longer. So parallel like that, from the center, and it should be in the middle, and it is. I'm happy with that, so I can connect that up. And then with that point there, because we know that's where our tangents start, okay, if I was to connect that through C, it should match up with this, and we'll see. Okay, yeah, it's actually working out pretty well. Okay, and you can see that they're matching up anyway. Okay, that's just another way of actually finding it. Okay, so from that point there, I'm going to extend out a tangent. Okay, heavy in that, and then do the exact same on this side. There's my tangent, heavy in that, and now heavy in my circle. Okay, so there's a little bit in this, guys. The next one is probably the one that most of us like. It is a translation where we move from P2 to P3, literally just like it's moving along train tracks. Okay, so just get in this bit here now. So there we go, guys. That is axial symmetry and now central symmetry, having found the center point and then the axis. Now we're doing a translation, okay? Translation is the easiest one. So what we're going to do is we're going to go from P2 to P3. Okay, like that. We will get that distance on our compass. So I'll take that distance on my compass from P2 to P3 and have that set on my compass. I'm going to leave that up there. And what I'm going to do is, like it moves along train tracks, I'm going to move all the points parallel along the line P2 to P3 in the same direction. So line it up with P2 to P3, and I'm going to project out Q2, and somewhere out here will be Q3. Same with R2, somewhere out there will be R3, S2, and then T2. Okay, and that's the idea, guys. And to find all of them, having taken these already, that distance there, we've already got P3. Now I want to find Q, so from there, that'll give me Q3, S3, just had that one right. On to the next one, R3, and then finally T3. Okay, so I can label all them. T3, Q3, R3, and I think this is S3. So same techniques again, guys. I'm going to line it up and just make sure that they're all parallel. Yep, so happy with that. And I always use the long edge of the 45, it's just a habit, okay, and because then I can swivel it about. Okay, and yeah, a little bit out there, so try and make it work. There we go. Not too bad. And from T3, I know it's perpendicular as well. That'll help me find that point back there. And if I wanted, I could see and check by going back parallel from the center. And it's close enough. Okay, so quite happy with that. And at that point there, I'm just going to move this down once again a little bit further. There we go. At that point there, I'm going to draw in my circle. Take it from here. Radius 25. T3 is the center. Okay, there's my circle. I will now connect up my tangents. Put them in lightly. Show the examiner I know where they're coming from. And finally, heavy in the circle. Okay, there's the center. So there we go, guys, that's that one done. So that's 3 out of the 4 done, guys. We've one more to do. Okay, and I'm just going to, I'll actually leave it down there, guys. I know this one's kind of out of shot, okay, but we've done it, starting here, we did an axial symmetry, then we did a central symmetry, and now we have done a translation. All we did was literally move it along train tracks, okay. The last one, guys, is where we have to do a rotation anti-clockwise at 90 degrees from P3 to P4. So first of all, you can get three kind of different types of rotations, guys. This is probably one of the hardest ones. So we're going to take P3 to P4, we're going to connect that up. Like that, okay? I'm actually going to put this part in green, okay? I'll go over that again. So I'm using a green pen here now, guys. Mightn't come up great on the sheet, but you'll see what I'm actually doing here, okay? So P3 to P4. Basically what we have to do is, that has been rotated because we know where P4 is. So technically that P3 has rotated anti-clockwise, so it means it's going back in this direction. If it was clockwise, it would go like this, anti-clockwise like this. So P3 has basically rotated 90 degrees until it came back here, okay? And anytime we're working with rotations, we have to think of, we're going using what is an isosceles triangle, okay? So if I connected up a line there, just did a line like that, okay, and bear with me now a second. I know in an isosceles triangle, two of the base angles are the same. So there's my isosceles triangle. You can see it there, okay? And we want to rotate, okay, P3, which is here, which I have now located here. It's like I'm just kind of putting it to the side, to P4, which is over here, okay? And technically that there is our rotation point, and we call that R, okay? So basically all I'm doing is I'm rotating P3 to P4 about R, okay? Just simply, with R as my top point there, down to P3. Hopefully this works out depending on my accuracy, but there we go. And you can see they have rotated to meet each other. P3 is rotated around to meet it. Now, they have told us that the rotation angle is 90 degrees. So that's why I did here. I went up like that. So that perpendicular angle there is 90 degrees in there. Okay? If this is an isosceles triangle, that means that this angle and this angle are the same as each other. Okay? So we know that the three angles in a triangle add up to 180. And if this angle is 90, 180 take 90 leaves 90. That means the sum of this angle and this angle is 90. And I told you that they are the same. So 90 divided by 2, okay, because the 90 that was left over divided by 2 equals 45. So that angle there is 45 degrees and this angle is 45. So that means, okay, from P3 I can go up at an angle of 45, and from P4 I can go at an angle of 45. Okay, so there's a couple of ways you could do this, and I'll show you now. Just trying to find my protractor there, guys, so apologies. Right, I found the protractor there, guys, sorry for that. So P3, as we said, we can go up at an angle of 45 degrees. So what I'm going to do is use my protractor. I'll just zoom in on this part so you can see it. Use my protractor with the center of the protractor on P3. Make sure the 0 is on the line. Okay, I'm happy with that. I'm going to mark up 45 degrees. So there's 40, 50, 45, right there like that. Okay, and what I'm going to do at that point then is connect the line. Like that, okay? And somewhere up along that line is my rotational point. I can also do the exact same at P4. Okay? So, center your protractor on P4. Make sure it's zeroed in down here. Okay? And read up 45. And we can see 0, 10, 20, 30, 45 right here. Okay? And literally, that's actually going out along the straight line. This is working out quite nice. So P3, and where the two lines cross each other, you can see where they've crossed, that one went out there. That point right there is going to be our rotation point. Not actually right in, I know I have an R over here already, but I'm just still going to call it R. Just put it in nice and big. Okay. Now, the other way we could have done it was, having got this angle here, which we worked out to be 45 degrees, because this angle up here is 90, so I'm going to put in a little perpendicular symbol in there. Okay, and then this one is also 45 degrees. Having done that, guys, what we could have done was we could have just drawn one of these angles, and the other thing we could have done was the line connecting P3 to P4. Now this will be a true test of my accuracy here. Alright, but the line connecting P3 to P4, Okay, I could have also bisected that line. Okay, and where those bisectors connect, point here, that should go through R. Okay, and this will be a test of your accuracy. I'm actually quite happy with that, and as we can see, look, connecting up, if I was to do that, that will go through R there. I'm not going to do it in because it'll just get a little bit confusing, but I'll put it in, just putting it in. I'll put it in that much of it there. Okay, and we can see there, once again, perpendicular angle. Alright, so we could have bisected and just done one of the angles and that would also give us R, or you could just use a protractor 45 here and 45 degrees here, okay, along the line P3 and P4, okay. So now that we've found R, guys, I'm going to zoom out there and we're going to rotate about all of those points 90 degrees, okay. So starting off, I'm going to get rid of the green now because that was just for explanation purposes. So starting off, what we're going to do is I'm going to rotate about Q3, about R. So Q3, I'd imagine Q3 is going to be somewhere in down here. I'm just guessing, okay? So to find out exactly where that is, what I'm going to do is I'm going to connect up R to Q3, like that, and then taking my protractor. Okay, remember we're rotating 90 degrees, okay? The 45 is just to help us find the R. We found the R, we want to rotate that 90 degrees, okay? So using your protractor, put your protractor on R, make sure it is zeroed in on the line connecting to Q3, protractor on R, 0, and then 0 as well is on the line connecting to Q3, and read about until you see 90 degrees, okay? Now you even read it wrong, so there's my 90. I'm going to connect that over. Okay, and as you can see there, I have to continue my arc. And there we go. We have now found Q4. Right there. I do the exact same with R and S and T. Okay, so connect R up to R3 in this case. I'll do the same for S just to have it ready. Okay, and what I'm going to do now is rotate and start off. Sometimes you can do the protractor first. So put your compass point on R and pencil point or biro point in this case in R3. It's going to be somewhere out there. And yes, I'm going to imagine somewhere out there, and I'm going to do the same for S just to have it done. Somewhere in there as well. Okay, so you imagine it's kind of rotating around like that. So imagine my circle is going to be up here somewhere. So with the protractor on R, and then I'm doing the R3 one, so make sure your 0 is on this line in here. Happy with that. There's my 90 degrees. Connect that over and just make sure you have the right line. That's coming out to this one. Okay, so that technically is R4, and now I'm going to do the exact same to find S. So on the R, zeroed in. Okay, I'm happy with that. On the R, there, 0 is on the line connecting to S3. Rotate around 90 degrees, because remember we're going anti-clockwise. There's my mark. Okay, and there was the S arc going around there like that, so it's cut it there. And this will be a true test of your accuracy now to see if these have all lined up parallel and perpendicular and whatnot. So we know P3 connects to S3, so P4 connects to S4. So I'll line that up. And what I'm going to do is I'm going to check then if Q4 and R4 are parallel. And they're coming out okay, probably half a mil out. Okay, and that has probably started somewhere else. It's not too bad. And now, rotate, perpendicular. I can check. It's not too bad again. Okay, and here you can see I'm a little bit out. But you try and make it work. So there we go. And at this point now, I have to find one more, which is my T4, T3, which is going to come up to T4. So T4 is going to be somewhere up there, I'd imagine. Okay, and connect that up to T4. And once again, just make sure you're on the right line so it's connecting to T3. Yep, there's my 90. So there's my 90 this time. Okay, just a little bit out from one other one. And there we go. And it's showing me there T4. Okay, and once again I can take my radius from down here. I can draw in my circle. And we know then we just have to find the tangent points. Okay, I know the tangent points are starting down here, so I could literally, because I have the line, scribe it around, okay, to the arc. It should cut through the middle, and you can see it's cutting right there. So at that point there, then I can connect up my tangents. So heavy that in. Just connect it back to show I know where I'm getting it from. Okay, and you can see there I kind of got it done. And finally, just heavy in the detail. So a little bit in that rotation part, guys. It's often the hardest part in the question. They usually leave it till maybe the third or the fourth part. Okay. Usually the first two will be like a translation or an axial and a central. Okay. So just get that done there now. Right. That is the question completed, guys. I'm just going to move it up there a little touch so you can kind of get the full picture. Alright, so as you can see there, guys, it does fill up almost the whole page. Starting off over here, we did axial through to the central, translation, and then a rotation anti-clockwise up here 90 degrees like that. Okay, and you can kind of see the 90-degree angles that have been created there. Okay. The hardest part of this question, guys, is finding the rotation point, but using the principle down here of an isosceles triangle. So if that was 120, then you subtract 120 from 180, leave 60. Therefore, this angle will be 30 and 30. But today it was 90 and so forth. Okay, and then it's just a case of rotating either anti-clockwise or clockwise, depending on the question that's given to you. Okay, that's the 2019, guys, higher level transformation geometry question. Hope you found that helpful there, guys. That's the question complete.